This video is on the objective make a conclusion and interpret the results for testing the difference between two population means where the population's standard deviations are unknown. And if that's the case, if the population's standard deviations are unknown, it means we're going to end up using the student's t distribution instead of the z, instead of the standard normal. And this is using the critical value or rejection region approach, usually just called the critical value approach. Right. So let's go to the problem I'm looking at. Now again, if you're unfamiliar with the topic, want to see more about it, please click on more instruction, look at their videos, their notes, their examples, and hopefully those help you. Pardon me. Alright, so here we have Laura Norris is a poultry farmer who wants to know whether different breeds of hen lay different numbers of eggs on average. A random sample of 60 values of the daily egg production by the Rhode Island red hens had a mean of 0.765 eggs per hen per day. And a standard deviation of 0.113. Another sample, right, from a different kind of hen, a different population. A random sample of 50 values of the daily egg production by the Plymouth Rock hens had a mean of 0.559 eggs per hen per day and a standard deviation of 0.092. So they're giving us a lot of information here after this. They're saying let mu1 be the population mean number of eggs laid per hen per day by the Rhode Island red hens. Alright, and mu2 be the population mean number of eggs laid per hen per day by the Plymouth Rock hens. Alright, so Laura assumes that the population standard deviations of these two groups, right, the Rhode Island Reds and the Plymouth Rocks, are equal, and uses the alternative hypothesis, that they're not equal, right? Because if mu1 minus mu2 was just not 0, that just means mu1 is not equal to mu2, right? So the null hypothesis is assuming they are equal. The alternative is assuming they're not, right? That the difference between the population means is not 0. With a significance level alpha of 10%, right? Alpha equals 0.10. Now, they're giving us a lot of information because all we're asked to do is make a conclusion and interpret the results. So if the test statistic, right, the t-test statistic is, a t-score of 10.34 and using 108 degrees of freedom, which would remember be n1 plus n2 minus 2 here, right? 60 plus 50 is 110, minus 2 is 108 degrees of freedom. The rejection regions are less than, a t-score of negative 1.659 and greater than the t-score of 5% above it, positive 1.659. What conclusion could be made about the population mean number of eggs laid per hen per day for the two types of hens? And identify all appropriate conclusions, right? So you're selecting either reject null or fail reject null, and then you're going to select one of these two things, depending on what the proper interpretation should be. Alright, so on some paper here, I'm going to write out what we have. Alright. The null hypothesis was that mu1 minus mu2 equals 0. Alright, she's assuming that the means are equal. And the alternative hypothesis was that mu1 minus mu2 was not 0. Alright, so this is a two-tailed test, which is why they gave us the two critical values. The value of the significance level was 0.1. Alright, so this is, remember, the area of all the rejection regions combined, right? Both rejection regions put together should have an area under the curve of 10%. Now they gave us all this information. We're working with a the distribution of x1 bars minus x2 bars, the distribution of the difference in sample means, they told us was a t distribution with 108 degrees of freedom. So I'll draw those, horizontal axis is, t-scores. It's a bell-shaped symmetrical curve. Underneath the peak is a t-score of 0. And then the critical values, right? They gave us the critical values. One in the right tail, one in the left tail, so that the area, right, the area of the right tail and the area of the left tail add up to 10%. Right, so this area over here is 5%, 0.05. This area over here is the same, right? Area is 5%. So that's why the two scores they gave us were t 0.05 and then the opposite of that. And they were given to us as 1.659 and negative 1.659. So there's our rejection regions. Right, and then where did our test statistic come up? All right, well, they gave that to us as well, right? They said the test statistic for this t-test was a t-score of 10.34. Yikes. 10.34, right? Here's our test statistic. And that is clearly in one of these rejection regions. So that means I would reject the null hypothesis, right, when I make that decision. Now, if we're rejecting the null hypothesis, I'm going to cross it out, we're rejecting it, means we're going to accept the other one, right, the alternative. We're going to lean more toward that and say the evidence supports that. Now let's just see how they worded it. All right. So basically, we're going to lean more toward concluding that these averages are not the same. Right. Okay. So let's see how they word this. So like I said, we're going to reject the null. And then down here, let's see. There is insufficient evidence at the 10% significance level to conclude that the population mean number of eggs laid by Rhode Island Reds is different than the population mean number of eggs laid per hen per day by the Plymouth Rocks. Well, that's not true. They're saying here that there's not enough evidence to support the statement that the means are different. But on my paper, I just said we are going to support that the means are different. Right? We're rejecting the null, so we are going to say that we have enough evidence to support the statement that the means are different. Right? So that's this statement here then. There is enough evidence, right? There is sufficient evidence at alpha equals 0.10 level of significance to conclude that the population mean number of eggs laid per hen per day by the Rhode Island red hens is different than the population mean number of eggs laid per hen per day by the Plymouth Rock hens. And that's all. All right. That's all we're asked to do when asked to make a conclusion and interpret the results. Right? So it looks like they're going to give us a lot of information. The test statistic in previous videos, from a previous assignment, you saw how to find that, right? Whether it was, now this would be that unpooled, actually no, a pooled scenario, but they didn't tell us all that. They didn't, you can tell it's pooled by the degrees of freedom was n1 plus n2 minus 2. So that's kind of how you can tell it was a pooled scenario versus a non-pooled. But anyway, we saw how to calculate the test statistic. We haven't seen, in other videos in this assignment, you'll see how to figure out these critical values, which are the same as finding critical values for any t-test. You just have to know the number of degrees of freedom and your significance level to find critical values. And that's it. All right, so do we reject the null hypothesis or not? You know, is my test statistic in a rejection region that's defined by these critical values or not? And whether or not we reject the null hypothesis, what does that say about our conclusion? What kind of conclusion can we make about the alternate? Are we supporting the alternate or not? All right. So hopefully watching me do this real quick here and looking at more instruction, reading your answer explanations, hopefully all this stuff helps you when you're doing this assignment on your own. And thanks for watching.